one of the, it's not a new concept to use open source printers for biomedical research. But really, there's an exceptional value for money that you get from this. There's no single company that sells these printers, so they never will go out of business. They're incredibly modifiable, and the cost is so low. You don't have to worry about having the warranty voided by opening them up and changing that you would have on a more expensive system. But still, that expensive system is needed later on in the pipeline. So this just fills in a certain point. You do need to have the ability to assemble 3D printers and have familiarity there. And of course, the precision isn't as high as the expensive systems, but it gets you about 90% there. And so we see that at the university level, there's an opportunity for that. We've adopted the MEWron 3D printer. This is really evolved from the original RepRap project in 3D printing. And this conversion of the MEWron to the MEWron is relatively simple, and there's a lot of nice aspects about it. So if I just show this short video of where we get the MEWron open source printer and this very small footprint structure, and what we can do is we actually replace some of the parts in there as we accommodate for the high voltage that's being used on both the collector plate as well as the head, which we have a whole bunch of parts which we push away, and we swap this over into something that is more amenable to doing melt electrowriting. And there's a lot of little features and details that you can go in and modify as well. So these are quite fascinating systems. They're compact, and they allow you to have filament-driven systems, which we're doing a lot more of, and these are great to work with, as well as syringe-based systems. The results as well aren't too bad as well. So here's an example of 1.5 micron. We have 300 layers stacked upon each other. And so the resolution of what you can achieve is really nice. It also